My name is Matthew Williams. I work for Flowroute. We have, well, first let me ask, how many have used KVM virtualization? How many have used Linux containers? Okay. So Flowroute is a enterprise class voice over IP provider. All right, I'll try to speak up a little bit. We're an enterprise class voice over IP provider. So we provide telephony services to other companies, various sizes. In our network, we manage about 100 minions, so we're relatively small compared to what some of you are managing. And we adopted SALT recently in 2013. So SALT has two relatively unique systems for virtualization. The first one being the Virt system, which utilizes libvirt, which itself utilizes KVM, VMware, and I think there are a couple other systems that can be used as well. But those are the main ones that I've worked with, really KVM. And then there's the LXC Linux container system, which is fairly new, and some parts of it very new as of last night. I'll talk first about Virt. So Virt is comprised of the execution module, which allows you to create, destroy, start, stop, pause, resume, various other ways of controlling virtual machines. Also allows you to obtain information about virtual machines. In addition to the execution module is a Virt Runner, which is really the interface that you'll primarily would use to work with Virt. It lets you orchestrate deployment of VMs. For example, it will find the least loaded host on your VM host machines to deploy to if you don't specify which host you're wanting to deploy a virtual machine to. It also, without the Virt Runner, you would not be able to pre-accept minion keys for your VMs. So part of what Virt does, as we'll see, is precedes the virtual machines that it brings up with salt minion, with a configuration for salt minion pointing to the master, any other custom configuration that you pass on the command line or pass into the Virt Runner or Virt module. And it actually pre-accepts the key that it seeds the minion with. The minion, in this case, being the virtual machine. So there's not a lot to getting a Linux system ready for Virt. You need libvirt and the Python libvirt library installed. You need a network bridge configured, and at least on Ubuntu, which is what I work with, the libvirt bin package actually does that for you. So apt-get install libvirt bin, and you're ready to go. You also need, well, you don't actually have to have a default bridge specified if you configure your bridge the way SALT thinks it should be configured. But on Ubuntu, the bridge that it automatically configures is named a little bit differently than what SALT is looking for. So you need this configuration either in your pillar or in your minion config. And really all that's telling SALT is to configure the virtual machine to use that named bridge. You'll also need for Virt a VM image. And there are a couple ways that you can do this. If you use VM Builder, you can go ahead and pre-seed it with Salt Minion. I like to do it this way. I think VM Builder works on both RHEL and Debian-based systems. And you can specify what suite you want, what flavor you want for the kernel, which you're going to want virtual. And go ahead and get the PPA for SaltStack and the Salt Minion installed. This will speed up the process of firing up virtual machines. If you already have Salt Minion installed, then the Virt module doesn't have to install Salt Minion in the process of firing it up. So pre-install the Salt Minion if possible. You can also download any KVM-enabled image and figure out how to get Salt Minion installed on it. And I can give you some details on that if someone wants to hit me up, and we can talk about that. It's not that hard to mount an image and get Salt Minion installed on it. So most cloud-ready images will also work. So this, once you've got your host ready, this is really all there is to starting a virtual machine. Salt run virt.init, the name of the virtual machine, number of CPUs, the amount of RAM in megabytes, and the path to your image. So the path can be, in this case, an image on the Salt file server. You could also pull it from HTTP. It could be on the local file system. It does cache it. So if you put it on your Salt master, as long as you don't change that, there'll be a copy of it cached on your minions, the host minions. And so that's a convenient way to get the same image out across all your minions. And Nick default really isn't necessary. I put it there since we set it up in the pillar in the example, but it will use the default profile. You can actually have several profiles, and actually let me just shoot back up to that page. So the default key, you could have also more than one interface. So you could have ETH0, ETH1, ETH2, etc. And you can use any of the libvirt's networking types. I apologize, I don't have details on libvirt's networking capabilities. It's sort of a subject in and of itself. But there's good resources online for libvirt. So you could have multiple Ethernet interfaces pointing to different bridges for different networks. You can have different profiles, and then in that case you would need to define your NIC profile. So what does this do? It'll select the least loaded hyper or host based on memory at this point. There is some intent to look at CPU load and disk utilization and so forth as well, and come up with an algorithm that will more realistically find the least loaded system. It caches the image to the local system, as we said, and then clones it. Once it has cloned the image, it installs the Salt Minion if needed. It configures the minion and pre-accepts the key that it generated for the minion, and it starts the VM. So once you have a VM up and running, I don't have it here, but you can actually right away run salt, the name of the new VM, test.ping, and you'll see it. You can get its IP address using salt. is it network IP headers, and maybe SSH into it, depending on the image you used. But if it doesn't have OpenSSH installed on the image, you've got Salt up and running. You can install it via Salt. You can create your users and so forth. So there's just a couple other commands that the Virt runner offers. Pause, resume, force off, start, reset. Does the same as this here. So. And finally, when you're done with it, purge it. And purge really wipes it out. And it also takes care of cleaning up the key. It didn't until recently, so if you're running off a stable branch, you'll actually have to delete the key manually. But the current developed branch of Salt will take care of deleting that key for you. So that's really all there is to Virt. And so I'm going to go on to, well, here's some URLs for documentation. You probably could find that on your own, but just in case you want to know the URLs, there you go. Before I go on to Linux containers, I take any questions on this. Yes?
So does this work with the, what kind of hypervisor is this?
This works KVM, which I think is available in recent kernels. And it also works with VMware's ESXi. I've not used it with that, so I only know that because I've seen it in the docs and in the code. But at Flowroute, we're using it on standard hardware with Ubuntu, LTS, so precise at the moment, and it's working quite well for us. Yes?
The salt create, or the convert create function, does that return progress of that?
No, you mean in the runner when you divert .init? Sort of, and I'll actually give a demonstration of the LXC, which uses a similar runner process, and you'll see. So it gives it gives some progress, but for the most part, it sits on one place, which is I'm creating the virtual machine. So yes.
How long do you get this all set up if you have, let's say, an image ready to go?
You mean how long to fire up a VM?
Well, no, I mean just to walk out of the room today and start setting up with the VM and my image and everything to get this going.
Sure. Not long. Assuming that you have hardware to run it on, right, with an operating system installed, half an hour, maybe less. Yeah, well, learning curve. Well, if you can do, what platform are you running on? Ubuntu. So apt-get install libvirt-bin will make it ready. All you'll need on Ubuntu is that to point to BR0 instead of BR0, which is what Salt looks for in your pillar, that gets distributed to the minions that are going to be hosts, and then you can start firing up VMs. Well, you'll need to do the VM builder, which you'll have to install as well. That takes, depending on the speed of your network, anywhere from 5 to 20 minutes maybe. So that's going to be your longest time, is getting that image ready.
How do you tell Salt which KVM servers it can use?
It actually identifies them based on the availability of the Virt module. So that could create some scalability issues in a very large environment where some of your systems are not. But it targets based on the. Right, if a minion has libvirt on it, it will consider it as a possibility. If you have, for what? What's that?
Can you blacklist menus?
No. But you can specify which minion to install in here you actually have a host keyword, and it takes a lot of the same arguments as the Linux container, the LXC module runner, and I have the more detailed docs on there. But there are quite a few additional arguments that you can give, and one of them is host, or maybe it's hyper for Virt.net, I don't remember. But there's a keyword argument that you can use to specify which host to fire it up on. Yeah, to be able to blacklist or create groups of hypervisors, that's something that would be useful for sure. Yes.
On the slide before this, you probably mentioned it, but I missed it. The VM builder or VM build command, where does that come from?
Yeah, the VM builder. You know, I don't remember the. I think it's Python-VM builder.
Okay, so that's a Python.
It's a Python script. But if you, yeah, I'll try to find the package that you want to install for that, for those that are using Ubuntu. There are a couple variations on it, so so I apologize. I'll figure out where I got that from. So, any other questions on Virt before we move on to Linux containers? No. So LXC stands for Linux containers, so they can be used interchangeably. And so Linux containers can provide a lot of the same functionality as a virtual machine, but they're not virtual machines. It uses kernel containment features such as namespaces, truths, C groups, and I'd say it's more like a virtual environment than a virtual machine. It shares the host machine's kernel and many other features of the host machine in a contained environment. So someone said it's like truths on steroids. But you do run a full system, can run a full system inside a Linux container, and that's the way the LXC Runner and LXC module are designed around that idea that you'll be running off an image of an operating system, which does not have to be the same as the host system. You can run Fedora inside an Ubuntu host. Also, because it's not virtualizing, you can actually run quite effectively a Linux container inside a virtual machine. And the demonstration that I'll give is doing exactly that. So the LXC, similar to the Virt, is comprised of an execution module and a runner, which is in the develop branch only. It was merged this morning. Or maybe it was last night. Yeah, it was last night it was merged. The LXC Runner is a wrapper around the execution module. It doesn't have a lot of meat to it, aside from the init function. The init function is essential to be inside the runner because it can do the pre-accepting of the minion keys for the containers. That functionality cannot be done on the execution module because the execution module is executed on the minion. So the minion can't force the master to accept the key. But the runner is executed on the master and is therefore able to accept the key. So it's got a lot of the same functionality. A lot of these slides are going to look very similar to the first set of slides. There's a lot of parallels between the Virt and LXC functionality, even though they're unique in what they're doing. So the getting a host ready to be, or a minion ready to be an LXC host is also very simple. On the more popular systems, at least, you just do an install LXC package. apt-get install LXC, yum install LXC. And on Ubuntu, there's a service that takes care of running a DHCP server. This is true of the Virt too, by the way. And that'll run an instance of DNS mask to provide DHCP services. Again, there are ways to configure your network. You might want to use Mac VLANs to bridge your containers or your directly to your physical network. But in the examples here, it's using a bridge and actually NATing. So that there's a simple SLS file that does what you need to do to get it ready. And again, you'll need to configure your NIC, and that's done same way as with Virt. And in addition to the NIC, you'll want a profile, which gives some details, provides some details to the LXC system about how you want to create your containers. And the profile, it has a name and a template, and there are a number of templates available that get installed with LXC. On Ubuntu, you have Ubuntu itself, which can take various arguments for the release. You have different options for your backing, and by backing, that's the medium on which the system will be stored. So you can have straight file system, you can have QCOW images, you can have LVM. And this example is with LVM, which is, I'm not going to go into too much detail on how to do that, but if you are familiar with LVM, you have an LVM volume group, and really all you need is to have that volume group defined, named LXC or whatever you provide here, and it will use that volume group. And you can specify the size. So you might have Ubuntu 1G, Ubuntu 2G as your profile names. And again, this can go in the pillar or in the minion config. If you're running more than one host, you'll find it more convenient to put it in your pillar so you can share it via targeting with all your host systems. So here is the doc string for the LXC runner. And it has a lot of options. A lot of them you don't need to specify in most cases. You do have to specify the host. The LXC runner isn't smart enough yet to try to figure out which system to put it on. So you have to tell it which host you're going to bring up the container on. I think that there will be some work on that. And in the future, it will also try to wisely determine which system to throw it on. CPU set and CPU share are C group controls, parameters. At least in our experience, you don't really need them because everything gets equal share on the system, but if you leave them out, it will let the systems burst as resources are available. So that it doesn't really gain a lot unless you need to have two different systems that you want one to be able to burst much higher than the other. But CPU set is actually a list of which CPUs on the system. So if you have 16 CPUs, you can do 1, 4, 8. There's nothing smart about it in the sense that LXC Runner is not keeping track of what other CPU sets are in use. So unless you're in a specific scenario, you'll probably create more headaches than you'll solve by using these settings. But they're there if you need them. Memory, on the other hand, you probably do want. And that will cap that container's usage of memory at a certain level and refuse to allocate any memory beyond that point for the processes running in the container. NIC, we already solved that. Profile also is one of the options that we saw. NIC ops allows you to specify a few details, such as the MAC address of the NICs. So you can say, and I don't have an example of that, but it is in the documentation. But you can tell it the MAC address for each network that's in the NIC profile. And these last three options, generally you wouldn't need them. Seed is telling it to seed the configuration, install whether or not to install Salt Minion. You can leave it to true, which is the default, even if you already have installed Salt Minion, because it'll detect that and proceed skipping the installation. Minion config, you can go ahead and seed any details that you want in your Minion config file. So you can put grains in there or whatever, and that just takes a flattened YAML string with brackets. So basically it looks like JSON. Here's an example. Utilizing the setup that we already have shown. So it's going to initialize and create a container named test on the host minion with the Ubuntu profile with 256 megs of RAM. And now, we didn't have a image preparation here. And the reason being that the LXC tools actually take care of that for you. So when we shell out to LXC create on the host, it will pull the Ubuntu image and then cache it. And that can take a little while the first time you create a container, but once you've created your first container, it'll cache the information that it needs, cache the data for that image on the specific host. So, each new host that you bring up will have to go through that process. LXC templates are customizable. They're just scripts, and you can actually create your own. We've done that so that we could pre-install Salt Minion and basically have a tarball image with Salt Minion pre-installed. The templates that come with it don't give you that possibility, but they're pretty easy to hack at. So this is also going to install the Salt Minion, precede the config and keys, and start the container. Again, we have ways to freeze and unfreeze, which is the LXC terminology for pause and resume. Had some discussion on that recently, whether to use the terminology native to LXC Virt and libvirt, or try to create a common. But oh, I have a mistake in my slides. In fact, it should be LXC freeze and LXC unfreeze. So apologize for that. And the power off and restart is just stop and start. And we have the LXC.purge as well to wipe it out. And that will delete the QCOW image, delete the files off the file system if you're using straight file system, delete the LVM volume, clean everything up, delete the keys. Just a note on backing, the simplest way is to simply use a directory on the file system for the LXCs, and it just roots into it. You get some extra functionality if you use LVM. If you're using the file system, you have no containment of the amount of space the container can use. It can use up whatever volume your LXC is configured to put, which is by default varlib LXC, I believe. So it's going to put everything under varlib LXC. So whatever you've got, whatever volume is behind varlib LXC can be filled up by a single container. So the easiest way to deal with that is to use LVM, where you create separate volumes, or QCOW images can also work for that. Documentation is online, similar to the Virt documentation, and that's all I've got. We are hiring, so if you're in the market, let us know. And if you have questions after today, feel free to contact me.